Sebastian då kommer prata om 3D bioprinting of films from cellulose nanofibers. Är vi redo? Ja. Då kör vi igång. Varsågod Sebastian.
Så, idag ska jag today I will speak in English of course. Today I'm going to introduce you to the concept of 3D bioprinting, especially when it comes to this fascinating material, cellulose nanofibers. I will begin by talking about what is cellulose. Well, cellulose is in fact the most abundant resource we have available to us. It is a biopolymer, meaning it is composed of molecules that are repeating in a chain, as you can see right here. Now, cellulose can be extracted from, most commonly, plants, because it's the building blocks of plants, the building blocks of trees, fruits, vegetable, and daily products that you can get from nature. It can also be extracted from algae and bacteria. Now, what I'm most interested here is something called cellulose nanofibers that can be produced from from cellulose itself. It is a material composed of fibers that have width in the nanoscale, hence its names, and lengths in the microscale. So they're extremely small, 100 times smaller than any strand of hair. And you can see these fibers in this image right here, individual fibers. Now, the fact that this material is composed of fibers makes it very thick, and thus it has a very high viscosity. It also is quite transparent, as you can see in this image, meaning it has a low opacity. So, in fact, the interesting thing is that cellulose can also be extracted from something called tunicate, which is in fact the only animal resource for cellulose. And from this we can produce very high quality cellulose with extremely long fibers. Now, to give you a comparison, I will talk about softwood, which is the most common source for cellulose as we compare it to tunicate. As you can see from the microscope images right here, you can clearly tell that tunicate has much longer fibers than softwood. And theoretically, this means that we can use the fibers from tunicate as a foundation to make films or objects out of cellulose nanofibers. So the purpose for conducting this research is in fact to try to explore the viability of 3D bioprinting, especially when it comes to cellulose nanofibers. And we're doing this with the intention of aligning the fibers, like I spoke about before. Because if we're able to align the fibers, make them go in parallel, chaining to one another, we're able to maximize the strength of our films. And we can measure this, of course, by looking at the mechanical properties, something I will talk about later. Now, the reason why it is important that we're able to show that 3D printing is a viable method for cellulose nanofibers is that the conventional methods, as of now, to produce a similar thing as a 3D printer can, it takes a few hours or even a couple of days. On top of that, it produces a lot of harmful chemical waste. While 3D printing takes merely 20 minutes, it's super fast, it's meant to be extremely cheap, and there's no chemical waste involved in the production of films. So now I'm going to talk about measuring mechanical properties, and we do this by stretching the film. As you can see in the image right here, to your left, the film is currently being stretched. While here, to your right, the film is stretched and it has reached something called a breaking point and thus is broken. Now, what we're measuring specifically is the percent increase of the film from its initial length. And this will allow us to determine how durable, flexible, and strong the film is. Now, during my investigation, I produced 3 different types of films using the 3D printer. One purely made out of tunicate to explore its fascinating qualities of having extremely long fibers. One made out of softwood and tunicate. One made out of softwood and hardwood. Now, the reason why I've been mixing and matching different materials is because this is one of the positives of 3D printing. You can print layer by layer different types of materials to get different types of properties. And thus, I wanted to see whether it made any difference in the process of the film and the properties it might have. Now, the results of this investigation showed, as we predicted, that films that had tunicate, these two right here, in fact were much stronger. They had higher mechanical properties, which proves that tunicate can be used as a foundation for films in ensuring their strength. But another interesting observation that was made was that films that had softwood in them were much smoother and more uniform, which is exactly what we want if we want cellulose to start replacing products we have today. On the other hand, hardwood made films much more brittle, rougher, and they crackle during testing, which is definitely not something we want. Now, this might be due to the difference in material or their pre-treatment processes, but further investigation and research needs to be conducted before any conclusions can be made. Now, these aren't any revolutionary results I have come up with, but what they do signify is that they signify a very important thing. They're a starting point for further research in the field of 3D printing, especially when it comes to cellulose nanofibers. This is an ever-emerging field, and currently 3D printers are being used together with cellulose to develop tissues and organs to replace for us humans. And what I find most fascinating about this technology that I've been researching is its potential for the future. The possibilities are endless. The dream is to produce a material that is extremely hydrophobic, extremely transparent, and extremely durable. If we're able to do this out of cellulose, we have a material that we can use in our daily products to replace plastic that is biodegradable, eco-friendly, and it is extremely abundant and not dependent on a finite resource such as oil. Now, we do not only stop with these properties, we can explore further properties such as its conductivity for both thermal energy and electrical energy. And currently there's being research done for something called quantum dots. Now, quantum dots are semiconductors that you can find in most circuit boards, and the special thing about them is that they're as minuscule as nanofibers. And this means that theoretically you could print in quantum dots into these cellulose films, and you'll be able to display information just as the LCD screen on your phone does. And this means that our future might contain of newspapers that have the potential to change what they display every day, providing you recent news, and they feel exactly like paper, but they are able to portray all the things your phone can do today. Now, this technology, of course, seems extremely futuristic, but it is in fact not as far-fetched as it seems. Hopefully, and certainly in fact, the technology for cellulose nanofibers will continue to develop forwards as it gains more and more traction during the years. And we will certainly see changes and the effects of cellulose nanofibers in our near future. Finally, I would like to thank my mentor, that could sadly not be here, Carl Moser, and our supervising professor, Gunnar Henriksson, as well as the partners of RAISE, which are Teknikföretagen and Tekniska Museet. And finally, I would like to thank RAISE for Excellence for giving me this amazing opportunity to explore 3D bioprinting, especially in the field of cellulose nanofibers. Thank you.